on X, and I give you, it's a given, that V, the potential, is 10 to the fifth times X. So that is a given. And this holds between X equals 0 and, say, 10 to the minus 2 meters. So it holds over a space of 1 centimeter. So the potential changes linearly with distance. What now is the electric field in that space? Well, the electric field, I go back to my description there, there's only a component in the x direction, so the first derivative becomes minus 10 to the fifth times x roof, and the others are 0. So Ey is 0, and Ez is 0. So you may say, well, yeah, well, nice mathematics, but we don't see any physics. This is more physical than you think. Imagine that I have here a plate which is charged, is positive charge. And the plate is at location X. And I have another plate here, say at location 0. I call this plate A, and I call this plate B. And this plate is charged negatively. So X goes into this direction. So I can put the electric field inside here, according to the recipe, minus 10 to the fifth, and it is in the direction of minus x roof. So x roof is in this direction. The electric field is in the opposite direction, and it's the same everywhere, and that is very physical. We discussed that when we discussed the electric field near very large planes, that the electric field inside was a constant, remember? And the electric field inside was sigma divided by epsilon 0, if sigma is the surface charge density on each of these plates. And we argued that the electric field outside was about 0, and that the electric field outside here was about 0. So it's extremely physical. This is exactly what you see here. The electric field minus 10 to the fifth times x. So the magnitude of this electric field here, the magnitude is 10 to the fifth volts per meter. What now is the potential difference? Well, VA minus VB is the integral in going from A to B of E dot dl. Well, I go from here to here, so I write down for dl, I write down dx, of course, because I call that the x direction now. So I will write down here dot dx. And so this is minus 10 to the fifth times the integral in going from A to B of x roof dot dx. Looks scary, but it is trivial. The x roof is the unit vector in this direction. And dx is a little vector dx in this direction. So they're both in the same direction. So the cosine, the angle between the two is 1. So I can forget about vectors, I can forget about the dot. And so this becomes minus 10 to the fifth times the integral in going from A to B of dx. And that is trivial. That is minus 10 to the fifth times the location. I have to do the integral between A and B. So I get here x of B minus x of A. And if this is 10 to the minus 2 meters, to go from here to here is 1 centimeter, I must multiply this by 10 to the minus 2, so I get that this is minus 1,000 volts. So A is 1,000 volts lower than B. That's what it means. And that's something that's very physical. Notice that if you go from left to right, that the potential grows linearly. This is lower than that. And if you, in your head, used planes like this, parallel to the other planes, each one of those planes would be equipotentials. They everywhere have the same potential. And gradually, when you move it up, your potential increases. But notice the electric field goes from plus to minus, in the opposite direction. That's always the reason that's behind that minus sign.